In this example, we want to prove that the limit as x goes to 3 of the quantity x squared minus 7x plus 12 divided by x minus 3 equals negative 1. Now first note that this looks like a big scary rational function, but it's actually not. It's actually just a line with a hole in it, because note that this top expression, x squared minus 7x plus 12 factors, and the x minus 3 will cancel out with something, essentially leaving x minus 4 up top. We start with the rigorous definition of the limit. The more times you write it, the better it sets in. So we have the limit as x goes to a of f of x equals L means that for all epsilon greater than 0, there exists some delta greater than 0 such that when absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. And then we add in this little 0 here to make sure that x doesn't actually ever hit a. 4 words or steps will help us remember how to approach this proof. Given, choose, suppose, check. So let's follow those to hammer out this proof. And again, this is a linear case, even though it doesn't look like it. It is a line. These proofs do become more complicated when you go beyond proving them for essentially lines. But let's dive in. Okay, so we start with given. So okay, we say, all right, first we write proof. Okay, you always start a proof by telling everyone that you're writing a proof. Okay, given some epsilon greater than 0. So this is telling us you can give me any epsilon greater than 0. I'm going to find a delta based on that epsilon that's going to be small enough. That's how this is going to go. Okay, so given epsilon greater than 0, choose some delta equal to what? We don't know yet. That's coming. Right? We work that out as we go here. Okay, then we say suppose. Okay, suppose that, well, what do we want to suppose? We want to suppose the if part of this if-then statement. So we're going to suppose that bit there. Well, what's a in our problem? We want x minus a to be less than delta. Well, a is always this bit here. So we have x, limit as x goes to 3. This 3 is our a, right? We can tell right here. That's where our a comes from. Okay, so I'm going to suppose that 0 is less than the absolute value of x minus 3 is less than delta. We still don't know what delta is. Okay, next we check. Check. What are we checking? We're checking to ensure that then absolute value of f of x minus L is less than epsilon. Well, what's my f of x? This whole thing here inside the limit is always your f of x. Well, what's my L? This thing outside the limit is L. What are we checking? We're checking that this absolute value of f of x minus L is less than epsilon. So we want to end somehow with less than, and then it needs to end with epsilon. Okay, so checking here. So we say, okay, absolute value of x squared minus 7x plus 12 all over x minus 3 minus a minus 1. So that's minus L. So I'm just going to change that to plus 1. Okay, so now we're going to do a bunch of work, and eventually we want to have this less than epsilon. So let's see. I'm going to go ahead and factor that polynomial up top. So we have x, let's see, what is that? Minus 3, x minus 4, all over x minus 3. And this is what makes this kind of a nice example, is that happens. Okay, plus 1. Okay, so this becomes absolute value of x minus 4 plus 1 is absolute value of x minus 3. Well, we already know, so our goal is always to find somehow this bit here, an x minus 3 in this. Here we don't have to do much manipulation at all. It just kind of popped out for us. So we already know that x minus 3 is less than delta. So less than delta. But we want it to be less than epsilon. So what can we let delta be so that this bit down here actually says less than epsilon? Well, let's just let delta be epsilon. So I'm writing here delta, let delta equal epsilon. Okay, sometimes it's just as nice as that. And now down here, we finish the proof, less than delta, but we know delta actually equals epsilon. And that completes the proof. Put in my proof box. Let's see how this flows. We took any epsilon greater than 0. So you can give me any epsilon you want. I'm going to choose delta, and I'm just going to let delta be that same epsilon. And then as long as x minus 3 is less than delta, which is epsilon in this case, then we have shown that the function minus the limit, f of x minus L, is, well, we already assumed that it was less than delta, but delta is epsilon in this case, and it works out quite nicely.